Hey everyone, today we'll be building our own SVG-based icon component library for React. We'll be using a tool called SVGR to generate our React components, and then we will package it all up together into a publishable NPM module using Rollup. Alright, so I've got the base of my project already set up. Right now it's just a bare bones package JSON, there are no dependencies installed. And then I have a folder called assets. And this is where all the SVGs will be. So as you can see, we have a couple of SVGs here. They are not all consistently the same size. The formatting is a little bit different too. Chances are they were exported by different tools. So this is a likely scenario that you may have. And this is where SVGR will come into play, where it will actually help us clean up some of this. Now, the idea is that we want to take these SVGs and turn them into reusable React components. And for that, we'll be using the SVGR tool. So the way SVGR works is it takes your raw SVG input, something like this, and it will turn it into a React component. As you'll see, it removes a lot of the redundant information. It cleans up the formatting of your SVGs, and depending on the options that you pass to it, it will set specific attributes and pass props to it and so on. Now, there are a couple of different ways of using SVGR. We will use the command line interface because we want to run it as an NPM script and then package up the output using Rollup. So the first thing we want to do is we want to install the CLI. And then we'll also need to install rimraf so that we can run the command to clean up our files. Alright, so we got the first two dependencies installed, and notice that we're installing them as dev dependencies because this will only be used at the build time. So we don't want to actually ship any of this with our bundle. Alright, the next step is we need to create a script to run our SVGR command. So I will call this SVGR, and then to run it, we say SVGR, and then we need to specify the output folder, and we will put this in the folder called src. Because it's generating the React code for us, we'll put it in the same folder as where we would have put our own code. And then we'll need to pass it the location of where our source SVGs are. So that will be assets. All right, now before we run the command, there's a couple of options that you can set, and we will be using some of them. So because we want these to be icon components, the first option we'll be using is icon. And what this does is it sets the dimensions of the SVGs to a value of 1 EM. And this will enable us to specify the size of our icons by setting the font style property on the CSS. Let's go ahead and copy that, and we will add it to our command here. Next, we want to be able to set a title for our SVG component, and this will add a title tag to the SVG markup and will help with assistive technology to correctly identify it. So to do that, let's copy this title prop command and add it to our script here. So this way we'll be able to set the title prop on our components. And the last option we'll be setting is called the replace attribute value. So what this will do, it will enable us to replace a specific color in our SVGs if one is specified, and replace it with the value of current color. And this will let us specify the color of our SVG icon by setting the color property via CSS. So let's copy this option and go back to our script here. Now we need to specify the old value and the new value to replace it with. So let's go ahead and take a look at our SVGs, and the value that we want to replace is this one here. You'll notice a bunch of them have this color code specified, so we want to replace that. Okay, so if we go back to our script, we're gonna say we want to replace this color, and we want the new value to be current color. So by setting this, when we use our components, we'll be able to set the color via CSS, and whenever this color is specified in the SVG, it will take on the color property instead. Okay, so let's save that. And now if we run it, can say npm run SVGR. And as you can see, it takes our SVG assets and it turned them into these React components and put them in the source folder. So if we open this up, you'll see we've got our React component defined here. It's got a couple of props being passed to it, title as we configured. And that's the array labeled by property. And then adds the title tag as well. And then you'll see the fill got replaced by current color. And then you'll notice that a lot of the information that was originally in here got cleaned up. So in addition to generating the React components themselves, SVGR also generates this index file for us where all of the generated components are exported. Now this is great because this is exactly what we'll need to bundle our code into a publishable NPM package. Rollup is a JavaScript module bundler, and it will help us take our code and bundle it into an ES module that we can then publish as NPM package. The reason I chose Rollup is it's easy to configure first of all, but it is also very good at generating code that is tree shakeable. So tree shaking, or sometimes referred to as dead code elimination, is the process of when a tool like Webpack bundles all of your application code together, and it uses static code analysis to go through all of your code and figure out what can be removed that is not used in your application. So when we bundle our package, we want to ensure that it supports the static code analysis as best as it can, and Rollup is excellent at that. This will ensure that we're publishing not only as small of a package as we can, but will also help consuming applications reduce their final bundle size. So this will help users on slower networks or on less powerful devices not have to download as big of a JavaScript file to run an application. Rollup also has a number of plugins that you can use alongside it, and one of the plugins we'll be using is the Babel plugin. This will enable us to use the Babel transpiler alongside Rollup, which will transform the modern JavaScript syntax, so ES6 and above, into JavaScript that can run in our target environment, which we can specify via the options. Now, to use Rollup as well as this plugin, we will need to create our Rollup config file. And in this file, we'll be specifying the Rollup plugins as well as any of the options that we want to use. But before we do that, let's install Rollup and the plugin itself. And these will be dev dependencies as well. So if I go back and paste that, and then you'll also need to include Rollup. Okay, now let's go ahead and copy that Rollup config that we saw here. We'll go back and create Rollup config.js, and let's paste that in. Now the first thing we're doing here is we're importing the Babel plugin, and then we're creating our config. So in here, we'll see the input as the source and then index file. So this is already the same one that we have in here. All right, and then the output, instead of the directory, we will specify file, and we will put this into a folder called dist, and then we will name the file index.esm.js. And then the format will be an ES module. Next, we'll see that we have our plugin specified. So in this case, right now we're only using the Babel plugin, and then it has a couple of options passed to it. Now let's go ahead and take a look at these options because we'll need to change a couple of them. The first one we want to change is the Babel helpers. Now, because we're building an NPM module that we'll be publishing, it's actually recommended to change the default to runtime. And this specifies how Rollup should bundle the Babel helpers into our final bundle. Now, by setting it to runtime, we will need to use it in combination with the plugin transform runtime Babel plugin, which we'll get to in a second, as well as specifying the Babel runtime as a regular dependency in our package. We will also need to tell Rollup that Babel runtime is an external dependency, so we'll need to set the external option to this. Let's go ahead and modify that. Say runtime, and then we will set external to this regex. Now notice it says that it has to be regex because the helpers are located at the nested paths. All right, so let's go ahead and copy this and add this to our rollup config. So we'll need to specify those as external dependencies. And now let's also take a look at the documentation for this transform runtime plugin for Babel. You'll notice that in order to use it, we need to specify it as a plugin for Babel. And the way you do that via the rollup config is we can set that as an option here. Like so. Okay, so let's save that. And next, let's finish installing our dependencies. We'll need the Babel plugin transform runtime. And then also the Babel runtime itself. Now, one last thing we need to do before we run this is we also need to set our Babel presets. Now, because we're writing modern JavaScript syntax, as well as using JSX in our React components, we'll need to install the preset env and the preset React Babel presets. So let's go ahead and do that. Preset env, and then preset React as well. All right, now that we've got our dependencies installed and our rollup configured, let's go ahead and finish up the scripts that we will need to actually run all of this. So first, in our package.json, the first thing I want to do is add a property called module. Now, this will be the entry point into our package. And if you recall, we specified output from rollup as dist index.esm.js. So let's go ahead, copy that, and specify that in here as well. So this will be our entry point into our bundle. Next, we'll need a command to run rollup. And I'm going to put this as a build script because that's what we're actually doing. And then to run rollup, you just say rollup. And because we're using the config file, you can just say -c. Now, if you named your rollup config something different, you'd have to specify that here. But because we're sticking to the default convention, you could just say -c. Okay, and the last thing we want to do is we want to clean up the source folder before it's generated. So anytime we build before our build runs, we want to ensure that that's cleaned out, as well as the folder that will be created by rollup, which is called dist. So we can run this as a pre-build script. So npm will execute this anytime you run the build command, and we'll just say rimraf src and rimraf dist. So this will remove both the source and the dist folder before the build is run. Okay, and one last thing before we run this, because I don't want to have to run the SVGR command myself manually, I'm actually just going to add this to our build script here. So I'll say npm run SVGR, like so. So let's save that and npm run build. All right, so what's going on here? Oh yeah, right. So we added our Babel presets, but I didn't actually configure it. So to do that, we'll need to specify these presets in our Babel config file. And if we scroll down here, we want to just run the default targets that are specified by the preset env. And in order to do that, we need to set it to the target's default setting like this. So I copy that, and in our project, we'll create a file called .babelrc. And in here, we'll paste this, and then we'll also need our React preset as well. So let's copy that. And for this one, we'll leave everything to default as well. Let's save that. Okay, let's try to run this again. And there we go. Our package got generated in the location that we specified. Now you'll notice that we have a warning here, and it says that React is an unresolved dependency. Now this is because React is also an external module, so we actually need to add that to this array here in Rollup Config. So we can just say React. Let's save that and let's run this again. And now, as you can see, our output is clean. Great, so let's take a look at the file that got generated. And if we open this up, you'll notice that it contains our React components, as well as some of the Babel runtime helpers and so on. But notice this thing here. If you recall, I mentioned how Rollup is great at setting up the code to be tree shakeable. And the way it does this is by annotating our functions with this pure tag. So this will tell the static analysis tools that this component or this function doesn't have any side effects, so it can be safely tree shaken out. Now, one last thing we can add as well is if we want to see the actual size of the package that was generated, there's another Rollup plugin that can do that for us. And it's called Rollup Plugin Filesize. So we'll install this as a dev dependency as well. And then if we want to use it in our Rollup config, we can just simply say import file size from Rollup plugin file size. And now we can add it to our plugins array here. Okay, so if we add that there and save, and let's run our build again. You'll notice we'll get a nice little info screen here with the actual bundle size. Now there's one last thing we need to do before our bundle can be published as an NPM package, and that is back in our package.json, we need to specify files as the our output folder. So this takes in an array. We just simply need to say dist as our location for our output files. All right, so let's save that. Now that we've got our package set up, let's actually go ahead and test it in an application. So I've already got an XJS app set up. This is just a simple starter template. And now there's a way to test our package without actually having to publish it to NPM. And we can do this by running the npm pack command. And then pointing to the location, to the folder where our package is located. And this will take anything that would have been published to NPM as a package, and it will put it in this file here. And then all we can do is simply say npm install, and then point it to the file. All right, so now this installed it as a dependency, just like it would from NPM, only instead of going to the registry, it looks in the local file here. All right, and now if we go to our index file, you'll see that I've already got a couple of the components imported from our package. And I just got some simple state here that alternates between the two icons. So as you can see, by default, we're not providing any of the extra props yet. We're not overriding the style. This is just what comes out of the box. So let's go ahead and run it. And we see here that we've got our icon. When we press on it, it changes to the filled version. All right, so now let's say I want to change the size and the color of our icon. I can do that easily just by setting the style property on our components. So I can say style, and if I want to change the size, I'll say font size is equal to say 10 rem, like so. And let's say for when it's filled, I want to also change the color. So let me just copy that here. And then to change the color, I can simply say color and then set it to a nice shade of pink. Okay. Now as you can see, when we press, it changes the color and also the size has changed. Now let's say We also want to add a title. Say this is our art outline. And then this one, say art filled. And if we go back to our code and inspect the SVG, you'll notice that the title is set here as well. Right, and that's it. That's how simple it is. Make sure to explore more of the options that are available to SVGR if you want to play around with it. There's also a way to provide your own templates. So for example, if you're not happy with the component that SVGR generates by default, you can actually override it and specify your own template. So there's definitely a lot more options if you have a more advanced use case. Right, but this gives you an idea of what is possible with this tool. So this will be it for today's video. I hope you found it useful and learned something new. Let me know in the comments below if you end up using this approach. Otherwise, thank you so much for watching, and I'll catch you all in the next video.